Hi, everybody. We're back. It's prime time. This is section 5.5 on the double angle identities. And we've already went through a couple of these, okay? Well, really kind of went through the ones that we were going to cover, but just not in every form that we were going to cover them. So this first one, if we remember, our identity that we talked about last week, the sine of a plus b was the sine of a times the cosine of b plus the cosine of a times the sine of b. And I kind of mentioned that there was this identity. If I, thought about, what is the sine of 2x? We can go through and find an identity for that. And it's called a double angle identity because it's a 2x instead of an x. All right, so this sine of 2x is sine of, say, x plus x. And it doesn't really matter what color I make those. Okay, so I have sine of x plus x, and then by my formula, I have sine x cosine x plus cosine x sine x. And we realize that if we collect like terms there, I get 2 sine x cosine x, right? So that was kind of our first one. Double angle, let's say DA identities. Double angle identities, we know that the sine of 2x is equal to 2 sine x cosine x. Okay, don't forget that identity. That one, I think I said last time, but does come up quite a bit in calculus, so you want to know that identity. Okay, now this other one, I kind of snuck in there, and I said prove it for extra credit, but it was using this original identity, that cosine of, say, a plus b was cosine a, cosine b, and then here the sign changes, sine a, sine b, or some identity for cosine. And I said, well, let's think about what is the cosine of, say, 2x. And we wrote that out as like this, cosine of x plus x. And then we did cosine x times cosine x minus sine x sine x. And we saw that there was an identity for cosine of 2x. So this is cosine squared x minus sine squared x. Now, the only thing about this one, and maybe I mentioned this, is that this can actually be rewritten in a couple ways. Because we're dealing with a cosine squared and a sine squared here, it is actually possible to write this guy entirely in terms of cosine squared, also to write it entirely in terms of sine squared. But this first version, I'm going to write, say 2 and then 1, that the cosine of 2x is cosine squared minus sine squared x. Okay. If you were going to remember a version of it, I would remember that one. Okay. So cosine 2x equals cosine squared minus sine squared. Those two identities right there, you do want to know for calculus. Okay, but if you know those two, then what I'm about to write here, you should be able to kind of figure out if you do happen to not like remember it or memorize it. I wouldn't really recommend memorizing because we kind of already know how to figure it out, right? Cosine squared minus sine squared. We want to think about what would happen if I replace the cosine squared with 1 minus sine squared, because it's equal to that. So I take this guy and I replace it with 1 minus sine squared. And then I have a minus sine squared, right? So altogether, that gives us 1 minus 2 sine squared. So this cosine of 2x is also equivalent to 1 minus 2 sine squared, just by substituting in that Pythagorean identity. Well, you might want to stop the video and maybe you can figure out the third one. that I haven't written down, okay? That would be kind of a good check to see that you understand what I mean. Okay, now, if you do want to pause it, you can. If not, then we'll kind of continue on. The other one, I'm going to write everything in terms of cosine squared. So I want to replace sine squared with 1 minus cosine squared. So this is cosine squared minus, in parentheses, 1 minus sine squared. Sorry, 1 minus cosine squared. So I'm replacing the 1 minus cosine squared, replacing that into sine squared. And then I simplify. So cosine squared minus 1 plus cosine squared. And then what does that give us? That gives us 2 cosine squared x minus 1. So 2 cosine squared x minus 1. Like I said, if you remember these two, then you have enough. And you can get these two from this one. Okay. All right, so I'm going to be doing a few problems now. And you are going to have kind of an Alex assignment on this. Figured I'd mix it up a bit. I think I'm giving you enough information to do it. But again, if you've got any questions, just let me know. And this one says find the value here. And it's 2 cosine squared of 15 degrees minus 1. Okay. So a couple different ways to think about it. One way would be we actually could find the cosine of 15. We did that last week. That's actually the harder way. The easy way is going to be to use these new identities that we have over here. So I kind of look at that and I kind of see this guy right here screaming at me, use me, use me. Okay, so what do I mean? Cosine of 2, let me color code this so you can see this really well. 2x is equal to 2 cosine squared x minus 1. Okay, so I'm color coding of it so you can think of it kind of as an input. Here, this is an x. Here, the x is here. Cosine of 2x is 2 cosine squared x minus 1. So this identity is always true for any value of x. If I think about what this is going to be, right? If it's 2 cosine squared of 15 minus 1, this is really the cosine of 2. And then times 15, because that's our x, right? X is 15. So this x right here is 15 in this case. So I hope you see I'm just putting a 15 in for x, if you will, into this formula, because that's what the value of x is in this case. But what is this? This is in degrees. So this is really cosine of 30 degrees. Do you remember what the cosine of 30 degrees is? Yeah, it's radical 3 over 2. So we've just found the value, and fortunately we didn't have to use that unwieldy difference identity for cosine, and we were just able to do kind of this nice double angle identity and get it real quick. Okay, let's look at another one. So how about this one? And this does, I would say, I don't know if you want to say fortunately or unfortunately, but it may come up in calculus, something, a situation like this. 2 sine of 22.5 degrees times cosine of 22.5 degrees. And what we want to do the same thing. We want to find the exact value. So we want to rely on this identity. Sine of 2x is equal to 2 sine x cosine x. What's our value for x here? I really see, first thing you should do, and you will see some tricky ones later on, but this is really the same as the right-hand side, except that x is like 22.5 in this case, right? So when I'm using this identity, this is really equal to sine of 2 times x is 22.5 here that. That's in degrees, right? So this is the sine of, that's 45 degrees. 2 times 22.5. And that's root 2 over 2, as we know. Okay. Hopefully that's not too bad either. Let's look at another one. What about if we were doing, let's say, cosine squared of pi over 6 minus sine squared of pi over 6? Well, you can see there we're really using this identity here. Cosine of 2x is cosine squared x minus sine squared x. Okay, so I hope you recognize that this is the same as this right-hand side. X is pi over 6. Right, so when we substitute this guy in, this is really going to be cosine of 2 times our pi over 6. Because that's what x is in that case, right? And then 2 times pi over 6. 2 over 6 is 1/3. So this really just is 1/3 here. So really we have cosine of pi over 3, right? Now, hopefully you have a unit circle, you have this kind of thought about. At least hopefully you know that pi over 6 is 30 degrees. Pi over 3 is 60 degrees. So this really boils down to what's cosine of like 60 degrees. Cosine of pi over 3 radians, that's 1/2 is that value. Okay, so kind of neat. All right, so we kind of want to do some now where maybe we're trying to find cosine of theta, sine of theta, tangent theta. Maybe we're trying to find cosine of 2 theta, sine of 2 theta, tan 2 theta. I'm going to do a couple different ones so you can kind of get an idea for what could be asked. Okay, so I want to make sure that the clock's still going because remember what happened last time here. So actually, you know what? All we're asked here is to find sine theta and cosine theta. Okay, and this is given cosine of 2 theta is 3/5, and theta is in quad 1. Okay. So what I would